In this video, I'm going to show you how to create cloud-free composite of Landsat imagery for your study area. It can be small scale, it can be global scale. So let's get started. In the previous videos, I already showed you how to create a composite using the median filter. And I also show you how to use the map function to create time series images. So this video will be just similar to the median reducer, but we're going to use a different function so that you can get a much better cloud-free imagery. So what we need to do, open Anaconda prompt. Then we just need to active Conda, activate GE, then type Jupyter Notebook, hit enter. It should open Jupyter Notebook on your browser. Then you can navigate to your directory. I'm under my documents, GE. Then I can create a new notebooks, upper right corner, new. You can choose a new name if you like. So I'm going to choose the cloud free composite. And so what we need to do is to import the library, Earth Engine, and also import GE map. Alt enter. Then we're going to create an interactive map. So gmap.map, and then the next line is to show the interactive map. Once we have the map, then you can, if you already know how to do the coding, you can write source code directly here. But I'm going to show you an easy way that you can grab some source code from the Earth Engine documentation webpage. So go to the Earth Engine webpage and then click platform documentation. Get started. And on the left side, scroll down to see Landsat algorithms. So click this one. On the right here, you will see a menu. So we are going to use this one, simple composite. You can also take a look at the simple cloud score. So basically, Google Earth Engine has some algorithm that allow you to quickly compute the cloud score for each pixel. And so when we're trying to create cloud-free imagery, we want the cloud score to be very low. So that basically we want the cloud-free pixel for every location. And then once you have all the least cloud pixels, then you can create a cloud-free composite. So we're going to use the last example here. Landsat 5 image collection for a single year, and as you can read from here, this is the Landsat 5. You need the original image. You cannot use the surface reflectance or top of atmosphere. Once you know the image collection ID, then you can filter, right? So this is by year, 2010, the start date and the end date. After that, you can just simply use the function ge.algorithm .landsat simple composite. Then you can pass in the cloud the image collection, and this is what you get. So basically, just one line of code, you can get a free cloud-free imagery. What we want to do is to click the copy button and then come back to Jupyter Notebook. So keep that in mind. This all the source code is in JavaScript, but we are working on Python, so we need a way to actually to automatically convert the JavaScript to Python. You can just click the icon and then look for this icon. So click this one. If you don't see this one, that means you might need to update your Python package. You can just type in here gemap.update package, and then parenthesis, alt enter. And if you update the package, then you can restart your kernel. Okay, so only if you don't see this one. And so I'm going to click this icon. This one basically helping you to convert your JavaScript to Python. And then you just need to Control V to paste the source code that we copy from the Earth Engine documentation webpage. Then click this one, convert. Okay, and you can now close. It's going to automatically convert the JavaScript to Python, and then what you need to do, you can just hit run. Sometimes you might get some error message, and this is normal because the automatic conversion module is not perfect. Sometimes you might need to do some manual editing. So I'm just showing you here unrecognized arguments type to convert an image collection. So if you look at this one, this is the issue that is coming from. And so within the curly brackets, additionally, So if you convert something from JavaScript to Python, sometimes you will come up with encounter this issue. And very simple, all we need to do is just put 2 star at the beginning. So because it is a dictionary, and in order to unwrap the dictionary, you need to have 2 stars, okay? Or if you can just parentheses and then collection equal to collection and then comma percentile equal to 75. It's the same effect, but it's easier to just put 2 stars in here, and then we can run this one again. Okay, so it works, and let's take a look. Nice, right? So you can see this is the cloud-free imagery, and actually we have 2 examples. So this is Landsat 5 for 2010 for the global scale, and the first one here, the composite, is just for the you just use the default parameters. So if you want to see what you can pass in, you can put your cursor inside the parentheses and then press Shift Tab on your keyboard to bring up the tips, and you can scroll down to see all the documentation. So this is the algorithm. You can pass in parameters, and this one computes the Landsat top of atmosphere composite from a collection of raw Landsat scenes, and that's why you see here from T1. And it basically calculates the score of a cloud score for each pixel, and then you select the base pixel. Once you have the base pixel, and then you just do the get all the pixels, and then composite as a one this cloudy scene. You might still see some clouds because some locations you have cloud all year round, and you're not going to get cloud free pixel. That's it. You can also look at the documentation here. You can go to the documentation webpage and then go to references. So from the reference, you can click the left side, cloud client libraries, and then click e.algorithm, and then Landsat composite, for example. This is cloud score. I think it's the next one. So you can see from here, it's the same like what you see from the Earth Engine, the Jupyter Notebook documentation, and you can look at here the description and all the parameters you can pass in. So this is why in the second example here we used the collection, but you can also use the percentile, also the cloud range, right? The cloud range is from 0 to 100. So if you want the least cloud imagery, you want this number to be a low number. So we can also turn on the layer on and off, right? Look at the cloud composite. This is the default one. This is the customized one. So the customized one actually have a bit more clouds in here, and you can zoom. You can zoom out to any location you like. This is global scale, so it's going to create the imagery for any location, right? So up to you where you want to do. And once we have the imagery, for example, this is the composite. You also have the custom composite. If you want to clip the imagery to a specific location, you can. So for example, in the US here, I'm just going to add the sensors data. I can just add just type sensors, and I'm going to add, for example, the sensors state, and then just hit import. Okay, so it's going to add a cell block here, and I can change the variable name to states, and also states, for example, and Alt Enter. So this will add the census data, vector data. And if you want a specific state, you can do that as well. So for example, I'm going to move here to Tennessee, and I can use the inspector here and then click this one. Because if you want to select just a state out of the entire vector data, you need to look at what kind of attribute it has, and then you can just filter by attribute. So as you can see from this one here, we have some attributes. So there's an attribute called name, and the value is Tennessee. So we can just here Tennessee equals to, so you'll be state dot, and then you can use the filter. So basically we're going to filter by attribute, and then parentheses. So within there you can have the filter called filter.eq. So that means we want to have a condition. If an attribute equal to something, then we take one out of the collection. So as you can see here, you'll be the attribute name is called name, Okay, so you be uppercase name and then comma and then double quotes and let's see. Okay, so once we have this layer, we can just map dot add layer, and then we can have Tennessee and then parentheses, curly brackets, and then I can say okay, and then Alt Enter. It's add that one to the map. You can see from this in here. Let me show it in. Uncheck this one. So now you should be able to see just one state being selected. If you want to change the symbology, you can simply use this one. Click here this settings icon, and then you can change the setting. For example, if you want it to be just the outline, you can do that as well. I'm going to change this one, and I can change the color, maybe to yellow color, something like that. And you can also change the line thickness. Just hit apply. Let me see in here. Sometimes there might be some time lag here. Okay, so the color it's still black. Then we can maybe change it again. Oh, we didn't change the color, so we can change the color maybe to yellow. Okay, and then we just hit apply. Okay, also need to remove the opacity so that it's transparent. So now you only have this one polygon. If we want to just clip to this polygon, we can do that as well. So under here, we're gonna, this is right now the composite, right? So we can just use the clip. We can maybe have another variable, maybe go tn clip equals to UV list imagery. Okay, so this is the entire imagery dot clip. Okay, you can also clip to feature clip to collection. Clip, you need a geometry, so we can just clip to collection and then use passing tn. Okay, next we can add the layer to the map, so you'll be tn clip. Also you can pass in the parameters, so similarly we can just copy this one and then paste in here. You need to change the name, otherwise you're going to overwrite the name. So I can say tn Tennessee composite, comma, and then Alt Enter. You might need to uncheck the original layer to see the original one. Okay, that's it. So you can see right now we have the cloud-free imagery. You can zoom in and then you can maximize. Really nice, right? So this is just essentially just one line of code. You can create the imagery for your study area. It can be any state. And so essentially you only did this line, these few lines. We don't use this one. And just how to add the layer to the map, and that's it. So simple and easy. Next, I'm going to show you how you can actually create multiple images, right? So as you can see from this one, it's only 1 year. How about if we want multiple years? Can you do that as well? Of course you can. So next, I'm going to show you maybe the other data set that we can use. This is using Landsat 5. We can also do that for Landsat 8 if you want. So what we want to do, go to here, click data, and then just type Landsat 8, enter. And so for the Landsat 8, we are going to use also the tier 1, the raw data. And this should be here, the collection 1, raw things, okay. And this is tier 2, we need the tier 1, OLI raw things. Oh, let me do it again, Landsat 8. And collection 1, tier 1, OLI, yes, this one. So click this one, and you should be able to see the image collection ID here. You just click import, and okay, so now it's here. So this is the Landsat 8, right? So this one is Landsat 5. We're going to use the Landsat 8. And also, if you want multiple years, you can also do that for multiple years. And last video, I show you how to do the mapping. So if you want to create multiple years cloud-free imagery, you can do that. So simply, I can just copy this one. So we can create basically a sequence, and then we can define a function actually to get cloud-free composite for each year. Okay, so what we need to do, we can just copy this one here and then come back to here. So this one I can say just maybe lane set, choose a name, lane set 8, and then we don't need to add a layer, okay, because it's just too much. We just need the ID, and then you can alt enter to execute. So next one, we're going to create a date sequence. So lane set 8 starting from 2013, we can just type 2013 and then up to 2020. Okay, so in this way we have 8 years, and so we're going to create cloud-free imagery for those 8 years. Okay, so this is the year. We can just, for example, years dot get info. Okay, plural. So 2013 all the way to 2020. So next one is that we want to create the cloud-free imagery for each year. So we can say maybe define a variable name called maybe called yearly image. Okay, and what you need to do is passing 1 year. So if you use the map function, basically we're going to map over this 8 years. Each year we're going to create 1. So in order to create, if you know how to create images for 1 year, you can do it for all the years. So define the year, and then next we're going to define the function. So all we need to do, we can simply, if you want, we can just copy this one, maybe paste it here. It'll be easier. So first we need to have the entire image collection, okay, and then we're going to just do the filter. How we're going to do the filter? We can, maybe we can just type collection, be easier, and then from here we can backslash, hit enter, and then indent dot. So we are just going to filter by date. Okay, so filter, we can just filter date, and then from here the start date will be 2013, and so maybe easier would be to have this one here, maybe have another variable called start date equal to, so it will be the year. So this year right now, this one is a number, so you need to convert that number to a string, and then you can just plus sign plus double quote 01 hyphen 01. So that means the start date will be, for the first one will be 2013 January 1st, and then you can have the end date. Okay, so the end date will be equal to start str and then year plus 1, so that it will be 2014, and then the same thing, this one here I'm going to show you. Okay, and once we have the start date and end date, we inside here, so start date and then comma end date. So essentially this one creates the imagery for each year, and also we are going to filter by Tennessee. So we can have this one here, again backslash, and then the next one will be filter bounds. Okay, so the filter bounds, we're going to filter by Tennessee. Okay, so this is the feature collection, right? And then tn. So once you have the feature collection, then we can create the composite. So we can maybe add another line. So the image equal to, so it will be list collection. So this is the feature collection, and we just need to apply this function. So if you maybe just copy this entire line here and put it inside here, paste. So length algorithm simple composite, and then you pass in the collection. So eventually we're going to have a cloud-free imagery just for that specific location. And similarly, if you can also do the clipping if you want, but we can do that later. For now, I'm just going to show you there, just this one, and then just return the image. Because after we create the image, we need to return, otherwise you won't get anything. Okay, so it's better to maybe move this one. You can move this one up here, because we need it to be here. Okay, so once you have this few lines, it's work. Okay, so we create your study area, and we also create a date sequence, and then we just define a function to create the base cloud-free imagery. And the next step is to actually do the looping. So we can maybe create another variable called images, right? So this variable is going to store all the images for those 8 years. So equal to, this is where we're going to use the map function again. Okay, net years dot map. We're going to repeatedly doing this for every year. So, and all you need to do is just passing this function years dot imaging. That's it. And let's do it. Execute, and oh, we have some errors. Compute object cannot do this for one. Okay, so it might, okay, so the year here means that this one is already an Earth engine object. If we don't convert that one to a string, then we cannot actually this is Earth engine object. It's not a regular Python object, so we cannot do it this way, but we can also use the other function, maybe called e.date dot from YMT. So this one basically is the Earth engine that can recognize, so it'd be much easier just using this one. And you can pass in the year, and then month, and then date. Okay, let me remove this one, and the other one is similar. Okay, so you'll be we can use the end date, the start date dot advance. So advance date just means you're going to advance for 1 year, so maybe here, and then just year. It should work now. So the start date is, for example, for the first one is 2013 January, and the end date is basically advanced for 1 year. That means they go to the 2014 January 1st, and then we can do the filter, create the imagery, and then you can repeat it doing that for all the years. So shift enter, shift enter. Now you should have this image collection created, and if you want, you can also images dot size dot get info. Shift enter to see how many images in there. Simple composite, no images in the collection. Let me take a look. Simple images. 1 second, let me do the debugging. Okay, so I just finished the debugging, and I noticed there was a typo. It should be LC, not O. So once you've fixed that typo, then we are good to go. So you can execute this one, execute, and you can take a look at how many images within the image collection. In this case, because we have 7 years, I think you can also change this one to 2013, because Lancet 8 has images from 2013. And we can execute this again, execute. So now we should have 8 images for this image collection. So essentially, we are creating the cloud-free imagery for your study area for multiple years. And let me turn off other data layers. And once you have all the images, then you can start adding the images to the map. So I can just maybe just take a look at the first one. I can first equal to images dot get. So first 0 will be the first image. The index is 0, and then you might need to convert this one back to an Earth engine image. Sometimes it's not always converted automatically. And then Alt Enter, map dot add layer first, and this. And say maybe first image, and see what happened. If you add the image, that means everything is being computed correctly, and you should be able to see this one showing up here. Let me take a look. It's still running. Okay, so now we have the image. We can take a look. You can turn off all other data layers, and by default it might be dark. So you might need to change the visualization. So we can come back to here if you want, right? So you can change this one if you want, but you can also click the inspector to take a look at the pixel values to see what's the, because in this case here we're using lane set 8, so the image pixel value might be different. Okay, so this one okay, still from 0 to 225, and we can, if you want, you can come back to here, you can copy this one, 180. So I'm going to maybe paste it here, create a new cell, and then put this one. I can say vis PAIM is equal to something. So the maximum here 128. We can see if it works or not. And what we need to do is just pass in here, change this curly brackets to the visualization parameters. We might also want to change this one maybe to 543, because lane set 8 has more bands than lane set 5, and if you want the force color composite, you might need this one. Okay. And you can shift enter to execute this one again, and we can wait for the image to show up on the map. So hopefully it will change to color so that we can see the image much better. Okay, so that's it. Now we have this much better image. This is for 1 year, but you can get that for all the years. And also you might notice that this image is not clipped to the boundary of the your study area. So if you want, you can come back to here, filter bounds, and you also want to just clip to feature collection. So just like what we did earlier in this somewhere, did we use the clip to feature collection? Yeah, this one. So you can just copy this and then come back to here, or you can directly use the copy to feature collection. Technically you don't need to this line, but it's better to have this one because you filter out all the other unnecessary images and then you clip. Otherwise, if you directly use the clip to collection, it's going to create a composite at the global scale and then clip. So that one will be more computational intensive, and that's why you want to filter first, and then basically you get this one and then you do the clipping. So let's execute this one more time, and oop, what happened? Image collection object has no attribute. Okay, then in this case we need to move this one down here, and let's execute this one because it's an image collection. We need the image first. So once we do the composite, then we can apply this one directly at the end of the image. If you get any errors, if you get errors, then you might need to wrap this one with the earth and the image. Let's run this one again, see if it works. Actually, we don't need the image size anymore. Let me comment out this one, and okay, then run this one one more time, and then come back to here. Hopefully it will show the image that has been clipped to the boundary. Not coming up yet, but okay, so now we have this one nicely has been clipped to the boundary of the state, and you can do that for any other states. All you need to do is just to change this one, and then you should be good to go. If you want to add all the years to the map, you can also do that as well. I'm going to maybe add another cell here, and you can just use a for loop, for example, for since you already have all the years. We convert this one to code. So from 2013 to 2020. So I can maybe for index in range. Okay, so it be 2013 to 2021 because the index is not included. The second one is not included, so it be 2013 to 2020. And then so all we need to do is just in here within the loop, you can say image equal to, it will be this one here, images dot get Oh, you might need to maybe just here use 0. It'll be easier just for you. And then 8. So it'll be index, right? And then you get the image. Convert this one to an Earth engine image explicitly. Sometimes it's like a computing object. It's not being recognized. So if you do the conversion, then you can use this one map.add there. Okay. And so for this one here, you can do the conversion. If you, I can also have the layer name. So layer name equal to, you can do that, for example, str, or you can, let me do it here, str, do this way, image, I say image, and then space plus. So the layer name will be, for example, image 2013, 2014, something like that. So I can do this, change this one to str, and then it will be the index plus 2013, right? So because the first index is 0, and then you plus 2013, it becomes 2013. So it will be image 2013. And the next one, the index will be 1. It will be 2014, image 2014, and that's it. So and then we can just hit 1. Hopefully, it will add all the images to the map. And so in this case, you have the time series images for all the years. And you will see here just a couple lines of code. It's not that complicated. Once you get used to it, it's very intuitive, so that you can create images for any locations around the globe. And so in the next video, I'm going to show you how you can actually, based on the image time series images you created, you can do all kinds of analysis. For example, you can create calculate normalized difference water index. You can compute NDVI or NDWI or whatever normalized difference index you want to create. And once you have that, you can do all kind of information extraction. So, but this is in here, this one here doing the simple composite. This one is doing that for the global scale. And then we clip just to the state of Tennessee. So it might take a while actually to run. If you simply just want, or because we forgot to add the layer name here, it should be layer name. Otherwise, it's going to overwrite. So you won't see actually the list of layers being shown up on the map in here. Oh, it's actually being shown up. That's nice. So you have layer 11. This one actually 2013. But you can, if you run this one again, you should be able to see 2013 and 2014. But let me turn all the layers off, and then you can turn on this one, right? Turn the Google layer. The other one. It might sometimes take time to actually to load. Oh, sorry. So that's why it's all the same. You need to change this one to image. So in order to be able to reuse those. So now let me. The best way is actually to clear up and run this from one more time so that you can get all the images. So I'm going to. This time I can comment out this one, and so at A. So essentially, these are not necessary anymore. We can remove them. So let's run this one more time. Okay, we create a map, and then we can create just for a specific state. For state is not anyway. So let's move this one up here. So we use the sensor state first, and then we do the filter, and then we add Tennessee to the map. And after that, we define how many years we want from 2013 all the way to 2020. Then we define the function to create a base image for the each year. Then we do the map function, basically the looping. And once we have that, we can add all the resulting images to the map. We don't need this line anymore. And then just run this one. Okay. Don't worry about that. I'm going to share the source code to the web page, so you can later download the source code from here to run on your computer, so that you can repeat exactly what I did. And so some of these source codes are just for your testing. So when you're trying to do something, you want to look for the examples. So the best way is to look at the Google Earth Engine webpage and look for examples. Then you can come back to here and you can use the map actually to do the automatic conversion for your study area. So in that way, you don't have to start everything from scratch if you don't know how to do that. If you don't know the syntax. So, and let's see here. It already has the first year. This might take some time to finish, but once it's finished, you should be able to see these time series images for all the for your location for all the years that you specify. So this is from 2013 to 2020, but if you use other year, for example Landsat 5, you should be able to see that for other years. Okay, so it's done. Then we can turn on this one. As you can see, right, from 2013 all the way to 2020, you can turn all the data layers off. And if you want to take a look at this, right, so you can zoom in to see the differences. So this is cloud-free composite. You can turn on, for example, 2014, 2015, 16, 17, 18, 19, 2020. Keep that in mind. It might take some time to load. So when you zoom in, you want to see more detail. Right now, it looks the quality is not very good. This because we are just seeing the overview. But if you zoom in, you should see more detail. So this is how you can create cloud-free composite for any location. It can be a state, it can be a country, it can be also a global scale. It depends on your interested area. Okay, so that's all for this video. And so if you want to follow the example, you will be able to I will upload the example here so they can download the example from this section here later. Okay, so I'll see you in the next video. Take care. Bye bye.